Hey everyone, my name is Paul Tarao and I will show you today DeepLLM, a system that allows you to cut to the chase when you use a large language model. Just ask a question, one of the kinds of questions that you see here, and everything else, the dialogue, the interaction, will be automated, which saves you time. So let's try out after, of course, pasting your OpenAI key in this little window, something related to causal inference, the origin of COVID-19, mysterious and thrilling. Let's activate the LLM and see what comes out. Things are not that fast because I use a reasonably clever caching mechanism, and you never call the LLM twice because it has a little bit of a cost here. If you do, well, actually, that's much less than a cent here, but still, if you go deeper, which you can, this is going recursively and explores the mind of the LLM as deeply as you want, in fact, but at a cost, and it also might take time if you go too deep. Anyway, let's look at some more interesting topic than this COVID in a minute. But let me show you a little bit what comes out in terms of structure of the information. Well, what you have here is, based on the causal inference, what could be the causes listed here. Those are alternative causes when you see the semicolon marking the end of the little statements or clauses that you can see here. So the origin of COVID could be animal to human transmission, wet market, pangolins, and so on. And now at the next level, you would see all of these explored. And when you see commas at the end here, it means that the wet market means animal trade, unsanitary conditions, close proximity, cross-species transmission, lack of regulation, and so on. So that's a conjunction here, while here is a disjunction. So alternatives versus things that all go together. Well, let's look at something a bit more interesting here. Let's see, assuming that you are a bit younger than I and want to get admitted to Stanford PhD in computer science program. Well, let's see what would be step-by-step guidance to achieve a goal. That would be your goal. Let's activate the LLM and see what happens. Again, this is not always that fast. It's because there is a bit of caching. So you would see here a number of alternatives for that. Good things that you need to do to get admitted, and then explored one at a time. Those are basically inferences. If all those things are true, then this becomes true based on the reasoning that's happening internally in the large language model, GPT-4 in this case. At the very end, everything that can be inferred from those consequences comes out, and that's called a model. So you can just forget about everything else and just look at the model. Now, you might also want to put a grain of salt in it and maybe say, well, not everything that's inferred here is as clear. You need a critique that moderates you. So in that case, you could decide that you want a different kind of large language model agents. For instance, the plain one is a recursor that just recurses, but you might want to go and use a rater here. And then the rater would give you some degree of confidence that you can control on this threshold here. We will get to that, but let's look at some simpler queries that could be interesting, just to see a bit things like supporting arguments for a thesis. Let's say that you believe that university tuition should be free, except for the courses you fail, which would then not be free. In that case, it's kind of an incentive here to study seriously. Let's see what happens if we go with that. So still just one level. And in this case, you would see that this is a new query, so it will take a little bit of time until it's coming out, not very much necessarily. And what you would see is, let me explain while this is working, some of the sliders that allow you to control various things. I'm not moving them because then my running would stop automatically. By the way, this is a Streamlit application that is deployed at DeepLLM streamlit.app, and you can just go there. All you need is an OpenAI key that you can acquire from OpenAI. It's very, very cheap, less than an ice cream per month so far for me. All right, so let's see what comes out here. It's controversial a bit, maybe. Free university promotes equal access. You can stream through this by running it again on your own, and eventually you get a model here. Sometime it might be interesting to see the cons and the pros of something. Let's see what would be the cons and the pros to vote, Republican in the next presidential election. This kind of goes well about one level down after that, because of the way negation works, it gets a bit trickier. So use this option, cons and pros, with just a maximum depth of 1. Activate LLM. Let's see what's coming out. Pros and the cons of a vote. And other options while this is working, you can get consequence predictions. You do something, or on the international scene something happens and you would like to see what would be the consequences, or something happens on the stock market and you would like to see the consequences, then you choose consequence prediction here. You might want to just use it as a good recommender system. It works, gives you really the right simple answers. All right, cons and pros for voting Republican in the next presidential election. Take a look at those and make up your mind. This could be a little bit left biased, but not very much. It kind of gets you the two sides of an argument in full detail. Very good to be adopted for politicians that, in this case, would just look for the supporting arguments for a thesis. Let's see how the supporting algorithm would be for that. then you would just see a one-sided story. Very good for advertisements or anything that's kind of one-sided and promotes a given idea. But I kind of like the consent prompts for whatever. Another thing that you can explore is scientific concepts. A scientific concept of your choosing, let's say, expansion of the universe, the Big Bang, I don't know, colonizing Mars, any of those could be explored and could be explored into a reasonable depth, but even serious academic concepts could be explored, like, I don't know, the existence of bias in large language models and what can we do to avoid that, and the presence of hallucination in large language models. Some of those still unsolved problems could be reasonably nicely explored. So let's get ready and see something a bit more less controversial than political opinions. Let's see what would be life working as a digital nomad from, little mistake here, but it's forgiving mistakes, actually. That's one of the nice things for large language models. Small mistakes and typos are fine. So let's see supporting arguments for a thesis. Activate the LLM, starting. So working as a digital nomad from a tropical beach house. You would see the advantages of that, and you could also see the cons and the pros for the same thesis. Using DeepLLM is just an option for this software module. Nothing stops you, if that's your preference, to actually go to the GitHub page of the of DeepLLM and then download it and play with it locally. You can also just say pip install DeepLLM, and then you get a copy of it locally that you could just, it has a very nice API, including this Streamlit-based visualization. So the pros of being a digital nomad and working from, well, form here, my mistake, but good enough to get what we call a model. Well, that's the story so far, and I would now show you how you could trim down the model to make it focused on something that's more likely to be true by having a rater. Let's look at buying an electrical car, also reasonably controversial subject, right? And we would like to see supporting arguments for that, but we would like only the really strong supporting arguments. As you can see here, even if you run it plainly, it's positively biased toward kind of buying an electric car, even if you run it with pros and cons. But let's see if we bring in an oracle. An oracle is a second opinion on the topic that would kind of rate it at each step of this recursive process. How likely is that whatever the other instance of the large language model thinks, is it strongly true, strongly believed, or kind of in between? my threshold is at 50% now, and I would activate a rater for that. So let's see kind of stronger arguments for buying an electrical car. Again, the system, well, the large language model might be positively biased sometime towards a given opinion or topic, and in that case, you can still squeeze by playing with the threshold here, just really strong beliefs that come from the large language model, if that's what you want. So this is a little bit longer when it uses the second instance, they kind of ping pong together to get to an agreed narrower model. So in the meantime, let me maybe show you my homepage quickly, and then my software at GitHub, and among them, the one that's pretty active these days, the recursors. So that is basically the project. It automates step-by-step reasoning, and there is a paper going with it that you can click on if you want and see a bit more details. This is how you could install it and work with it locally, and that's the paper that you can read if you have an academic interest and want a bit more detail. I think it's even on GitHub directly. It's a draft paper about it. It's full automation of goal-driven large language model dialogue threads with and/or recursors and refiner oracles. So currently what's working here is the refiner oracle. Looks like it's still working, all right. So if we go in some of the more advanced features that are hiding in this folder, you would see that you can use a local LLM. In my case, it's Vicuna running on the Linux nearby, which could work at zero cost to you, except for the humming of your GPU card and the electricity that it consumes. You could work locally quite well. Vicuna is a pretty strong model. The 7 billion runs on a good 3090 GPU card, pretty fast, maybe 5-7 seconds for a given question, back and forth. So the demos related to this would be having a few other requirements, like in this case, you would need fast chat to actually activate the Vicuna. Don't run Vicuna on a Mac or on something that doesn't have a GPU. That's more or less hopeless. Takes really a lot of time. GPUs accelerate by at least one good order of magnitude. So the other demos that you have here are a bit lighter in terms of requirements. All you need is a fast sentence segmenter and then the Wikipedia API. So this is something that allows you to test ground truth. So what's ground truth? Well, something that comes from a reasonably reputable resource that is a local document, and each time when a recursive step is made by the large language model, it's compared in terms of semantic distance using a vector store to the local ground truth that you have there. And with that, you can have a few interesting demos here that there are some examples. You can test raters, and the truth rater is the one that allows you to fetch something from Wikipedia or other document, a PDF that you crunch and transform in text, one sentence per line, and then that becomes your ground truth that controls the evolution of the recursion from query to query. All right, let's see if we have any progress here. It looks like buying an electrical car supporting arguments is quite heavy, or maybe Streamlit is now a bit heavily loaded. So what I will do, well, I could very easily start my local copy and show you how things go locally. But let me maybe just stop this one here and go for a simpler example. Let's see just a consequence prediction here, just one level, no rater, just a plain recursor. And then let's see some, buying an electrical car eventually came out, even if I didn't stop it. Well, lower cost, reduced carbon emissions, a lot of good things here. And that's the model. All right, so consequence prediction now for something bad, using tactical nukes in Ukraine. Let's see what would be the consequences of that, like a little warning for slow-thinking politicians that could go the wrong way. Okay, so that hopefully comes out a bit faster. Consequence prediction then. And while this is working, let's go and see a little bit more about how the system is actually organized, everything in it. So for that, I will just go to our top level README. Is our README, and I will tell you a few words about the API. So once you install it with pip installs locally, you can, in your own Python program, to have something that looks like this. For result in run recursor, here is the initiator that I just mentioned using tactical nukes. Prompter would be the consequence prompter, and this would go up to level 2, takes a little bit longer. And similarly, you can look later on a more interesting topic, which is artificial general intelligence. Will AIs get to human level or further down intelligence levels? And that's an exploration of that with a given threshold in this case. And you can see the results printed. The results are printed also with a longer trace, which I disabled by default not to have too much running on the screen here. But I will, so this is the bad stuff about, using tactical nukes, and especially if you go more levels down, you would see the consequences. So let's see if I enable the trace. The trace would be the reasoning steps. Now, hopefully this will be fast now because it has already the cached interaction with the large language model. So what you have here is a trace. The trace starts with the prompt. Actually, it's the pattern of the prompt, right? We use dollar context and $G for the goal that you want to explore here. And you could, that's just a Python dictionary, you could create your own prompt. There is an AND component that is the sequence of things that you need to do all together to achieve something. And then the OR prompt, which is the alternatives that would lead you there. So it's basically an AND OR tree, right? You can do this or this or that, but once you pick one of those, you can do this and this and that to achieve that particular objective. So here you would see the steps. Using tactical nukes would bring increased civilian causalities and then humanitarian crisis and so on, okay? Escalation of conflict and displacement of population and so on, okay? International intervention here if there is escalation of conflict. So you see that basically what you have here is consequence prediction step by step. So it should help a decision maker about making a good or a bad decision. Eventually, what comes out here would be well, a logic program in this form, right? If you do this, the consequences would be related to that. So that's actually a prolog program that can be run independently, but there is a model model generator inside, because this can have little loops when the large language model walks on the same path twice. So plain Prolog would not run it properly. That's built in and it's in Python and it's part of the code. You can play with it if you want. Well, I guess that's my story about this little program that I just put on Streamlit. Play with it and enjoy. So here we are. This was my friend actually that more or less helped me. Actually, I could maybe show you the slides that another large language model, this time is Claude, that has a much larger buffer made for me to present this paper, because I'm not very good with presenting things really. I'm good with making them. This is what's in the paper. It's an overview of this recursive descent frameworks and Claude. Claude comes from Claude Shannon, who in a paper in 51 kind of sketched it all, except for the high performance that happens now in terms of generating the most likely next word or next character in a sequence. Claude Shannon did it just based on probabilities, but the main idea is not that different. So that's what we have here as slides. And then there is a connection with logic programming that, of course, Claude picked much quicker than I would myself as an author of the paper. And those would be some of the things that refiners bring you, refiners being the oracles that make the reasoning a bit more focused. But at the very end, really, the consequences of that is that the content of the slides were generated by Claude 2, 200K context AI from Anthropic. This is the link to it. Go and explore it. It's much more flexible than GPT-4. After digesting in a few seconds the PDF of the paper, you just throw in the PDF and then enjoy talking about it. So this kind of disrupts a lot of hard and tedious work that a lot of researchers in natural language processing and document understanding did in the past. Anyway, take a look at the paper if you want, and enjoy the disruption that large language models bring to the world. Bye for now.